Yeah.
Here we go.
Welcome to the Hackaday podcast. My name's Mike Szczys. I'm editor-in-chief of Hackaday.
Hey, I'm Elliot Williams. I'm managing editor of Hackaday.
This is episode 128. Today we're talking about 3D printing injection molds, squiggly audio tape, curvy mirrors, and space cadets. Elliot, the Hubble is breathing once again.
Yoo-hoo! More Hubble!
It was in trouble for about 2 weeks in that it was put into kind of like safe mode. It had powered down and they were trying to figure out what was going on. And, taking it slow and methodically since it is an ancient relic out in the void there, they figured out that it was actually a 5-volt power rail that was causing the problem. And I think they're unsure whether the power supply itself is broken or if the way that they're measuring it has broken. But they managed to get it going again. They just switched over to the redundant power supply and they were able to bring things back up. The scientific instruments are still in sleep mode for now, but this is really good news for continued observation from that.
Hubble is like the space telescope that keeps on going. It's been, end of life, I don't even know how many times over, and it just keeps on putting out the science despite all of its troubles. I'm really stoked. It's awesome that they just happen to have a backup power supply on there, and they're just like, oh, well, we'll switch on the backup power supply. But they don't have a backup power supply. So this one's it. When this 5-volt supply goes out, somebody's got to go up there with a long USB cord and plug it in.
Yeah, and the last time that they switched stuff out was 2009. And so that is 12 years thereabouts.
Yeah.
So, cross our fingers, this could take us into the 2030s.
That is a lot of bonus science. Well, my news this week is significantly sadder. It's Samsung Shutter's original SmartThings hubs. This was a line of home automation. I guess it was kind of Zigbee hub that Samsung was running. This was an interesting one because it was kind of aimed at do-it-yourselfers and people who are a little bit more savvy. And that's a smaller market. And so Samsung is shutting it down. They don't want to do software support anymore. It's a 10-year-old project, so I guess that's okay, unless you have one, because they're bricking them and are kind of retargeting, as their press release says, more casual users than power users. So boo for our people.
Yeah, that's too bad. I really see meaningful home automation as a DIYer thing because you can't just buy an off-the-shelf thing and have it work for whatever you want. You've got to have some interactive programming in it. You got to figure out which devices are going to, create your home theater look or put your shades up and down at a certain time of day and how that is all going to tie together. And I often look at smart homes and I think about what happens when you sell that house.
Right. You have extraordinarily good documentation naturally to pass on to the next owners.
Yeah, you just send them a link to your GitHub README and then they take it from there.
Yeah, I guess X10 was the really old home automation protocol that kind of, assumed that, knew a little bit what you were doing. I think what's missing here is some kind of open interoperability standard that lets people plug things together who know what they're doing. Because they're trying to, on one end, do these kind of closed gardens for idiots. And then on the other end, there's the complete do-it-yourself route. And I guess there's kind of this middle ground that's served by a lot of open source software and hardware projects, I guess. But there's nothing commercial in that space. So I'm thinking of the Open Hab or the ESP Home or the Tasmodas of the world, which kind of aim to make it really easy to do it yourself, but then are still a little bit too complicated for the quote casual users. Anyway, I think there's room in the industry for someone who's really smart to put this protocol together and sell a mazillion of them.
This is a journey into sound.
What's that sound?
What's that sound?
What is that sound, Elliot?
That sound is the sound of a million hackers who all knew the answer to last week's challenge. What's amazing this week is that out of 38 answers, 37 of them were correct. Okay, so maybe it was too easy. The only one that wasn't right was submitted by Jeff Bezos, pronounced,
What?
quote, Bezos. And his answer was, that is the sad game over music that will play in Richard Branson's heart when I beat him to outer space.
Oh, that's very heartwarming.
Isn't that sweet? I love it when Jeff Bezos writes us in. It's really, really nice of him. Everyone else, including Nate from Chile, from Detroit, Jared in Beijing, neither Mike Stitch nor Elliot Williams.
That's a good one.
All of you got it right. So congratulations to everybody. That means super random number drawing. And this week,
how are we going to pick that?
And this week, I picked my favorite random number circuit. It's a reverse biased transistor circuit. I'll throw schematics in the show notes. It puts out about a megahertz bandwidth of white noise. And I'm plugging this into a microcontroller, reading the ADC a whole bunch of times. How many times? Let me actually check. 50,000 times, just for good measure. It ends up with a really big number. And this really big number, when you modulo it by 37, will give us today's winner. So a drum roll, please, for quantum mechanics. And the number is 109,632,180. Modulo 37 is 33. And looking up on the list is... Congratulations, Big Mike Kupka. You are the proud owner of the limited Hackaday podcast t-shirts. Congratulations, Big Mike. Sorry, everybody else. There will be something cool next week.
Did I just totally blank out when you said Ocarina of Time?
Did you what?
Did I just blank out? Have you said Ocarina of Time already?
Uh-oh. Yeah, no, you're right. And as all of you guessed, this is the theme music from Legend of Zelda Ocarina of Time. Done.
Let's get into the hacks.
My first hack this week is injection molds from your 3D printer. And this is a video by The Craftsman. I don't know if you've seen his YouTube channel. He does a lot of models and, just kind of extraordinarily detailed setups and model building things. In this case, we're featuring it because it's a really neat technique. And what he's doing is he's got an injection molder that squishes melted plastic into a mold. The gimmick here is he's making the mold itself out of a resin 3D printer. So one of these UV curing resin 3D printers. Normally you would make one of these molds out of aluminum, but that means you have to mill aluminum, and that's expensive and a hassle.
Oh, but it's not just the milling, right? Like the polishing process for those molds is crazy, and this entirely sidesteps that.
Ah, right. Yeah, I'm sure. And here he just makes aluminum frames that he gets to reuse every time, and then he prints a mold that then fits inside this frame. The advantage of resin printing here is not just the high resolution and the smoothness, it's also the temperature stability. And this I hadn't thought about until seeing this video, but because resin cure doesn't rely on heat like fused filament 3D printing, hot plastic noodle 3D printing, you can make something that can stand up to extra heat, and the pressure is contained by the aluminum case. And so he runs a bunch of models on these and does 10 or 15 kind of soft plastic models out of one mold, and it doesn't look any worse for the wear, which is pretty cool. There is a ton of detail here.
I think this is really cool because it has the potential to expose a lot more people to what injection molding is. Like injection molded stuff is all around us all the time. And I think people don't think of how that happens, but you could set this up at like a maker fair or your open day at your hackerspace, or the farmers market, I guess, if you wanted to, and have people come in and see you squeeze out these models and then pop them out of there, and they can take them home with them. Because after you get through the setup of having the injection molding machine and buying this aluminum frame, to print a new insert that has the void for the model itself is pretty easy. And there's some post-processing. He talks about getting the thing to be flat so that it mates well and that sort of thing. But the cost is pretty low once you get past those initial investments. The thing I hadn't thought of until just now looking at it, Elliot, where does the air go when you inject the plastic?
Oh, right. Yeah. So there were two things I learned from watching this video. And one of them was that he has these kind of, I don't know what they're called technically, but to me, they're like micro sprues This model has feet and I don't know what, antenna eyeballs or something. And coming out of his feet and out of the antennas are these tiny, tiny little channels that are small enough so that they'll let air out, but so that the plastic won't go out them. And so he actually doesn't have to trim off extra plastic from these micro sprues either at the end. It looks like he's got his technique down so that he's got just the right amount of pressure to fill the mold up perfectly, but then not particularly overspread it. And so that was a really cool technique here. And again, this comes basically for free with the 3D print. You just make a tiny, half a millimeter, third of a millimeter little channel in the CAD model, and boom, out it comes. The next step for him is probably going to be doing clay models just because he likes to work with clay, and then 3D scanning them so that then he has a model to make the 3D printable mold out of and iterate this process a little bit further. And that's also really cool because it lets you kind of combine the reusability of having a digital model of it, and that gives you then the ability to just print an infinite number of molds. Like even if one of your molds does wear out, it's not hard to make another one. You just hit go on the 3D printer. So this is developing into a very strong, capable, and interesting process for making a whole bunch of little injection molded things. Really cool.
I really enjoyed seeing a video from TechMoan this week that showed off a piece of telephone infrastructure, I guess you would call it. So back in the day, before there was, a digital telephone system, mechanical things that connected, copper to copper and let audio signals transfer from your home to the other end were the standard for the day. But how would you do automated recordings in a system like that? And this little box is meant to go into the telephone exchange and plug into it. It has the ability to automatically answer or be connected when someone dials like a wrong number or when they dial like an information line, and it will just play in a continuous loop a recorded message of tape. And the thing that'll catch your eye immediately on this is the top of this box that's about the size of a toaster oven has a glass lid, and underneath the glass lid is magnetic tape sitting on end and in kind of disarrayed loops. And so instead of being wound up on like two reels and then you'd have to rewind it at the end of the message, this just shoots the tape out one side and pulls it in the other side, and it kind of just lets the laws of randomness figure out where the loops go and how they sort themselves out again.
And if you've ever played around with old studio gear, this is exactly like a Roland Space Echo. And if you haven't seen a Roland Space Echo, get yourself some videos of it. It's got the same thing going on the top, which is this like crazy wound up tape path that's just free to flop around and makes these random patterns. It's totally mesmerizing, both in this like telephone answering device and in the trippy old Echo unit. The Space Echo was super influential in like the early Jamaican dub scene. And so I always have in the back of my head, like King Tubby or something stoned out of his head, just watching the tape spiral around in this thing. And I guess same thing probably happened for like the dial message people.
Well, TechMoan at the end of the video shows another cool piece of gear that is used to duplicate master cassette tapes. And it has a much, much longer loop because if you think about how long the cassette tapes were. But, at some point you had to, get the audio onto the tape itself. And I'm not sure if that was always the standard, but it was one way of doing it. You just put your new tape in there and it would run through the loose loop. It was that one was like on the front of a like console size machine, and it would just run through it that way. When he opens this one up, there's a lot of cool stuff to be seen inside, but unfortunately it's not working. He's able to get eventually some sound out of it, but it's not working as expected. And the same day that this article was published on Hackaday, another YouTuber that goes by Look Mum No Computer put out a video where TechMoan had sent him, or they'd met at a gas station somewhere and handed over the machine, and he has his own functioning telephone exchange. And so he sets out connecting it up to the telephone exchange and repairing everything that's inside. It's a wonderful look. You get to see cool things like on the front panel of this, there are trim pots that have a threaded nut. And so you loosen the threaded nut and then adjust the trim pot, and you can tighten the threaded nut down again to hold the trim pot right there. And that's how you set the volume level for each of the 2 dial-in phone lines. The message on this one, you do get to hear it, is, sorry, you've dialed the wrong number. Please hang up and dial again. You will not be charged extra for this. And it's just kind of a piece of nostalgia for anyone lucky enough to have lived during those early telephone days.
My next hack this week is finding fractals in the 1930s, and this is a video demo by Code Parade. It's a thought experiment of whether you could make fractals without computers, like just with analog electronics. And in particular here, he's trying to make them on like a TV screen. And the trick is really clever. When you point a camera at a TV screen, for instance, you know how you get that like infinite regress, that like tube of the camera taking a picture of the screen, taking a picture of the camera, taking a picture of the screen, taking a picture of the camera, taking a picture of the screen, going in forever. That's pretty cool. The gimmick here, though, is that you, instead of having a screen, you have multiple projectors and then you can overlap them. And that's what makes it fractal in the end, is that the image that's being fed back into each of the overlapping effective displays combines with each other where they overlap. And it's really great effect. You should absolutely watch this video because, you know, you need some source to start the thing up. And so he's moving his hand in there, or a pair of scissors, or a piece of paper, or whatever. And where that image was, because it's getting repeated through this like infinite loop and multiplied through the 3 different ways, it ends up staying. And so you get these kind of strange ferns that grow out of like your hand or scissors or whatever. The software for doing all of this with a webcam is posted up here. So if you want to run this software on your monitor that mimics this projection, you can do it yourself at home.
I like the concept of propagation delay with this one. So like the only reason that this works is that there's a delay between what the camera sees, putting that image back onto the screen. And so, you know, if you like run your finger through the edge of the frame, it adds that noise, and then you get to see that noise cascade delayed by that same delay loop each time. And that's what, you know, like the triangles within triangles within triangles effect is done. And you, like, I was thinking about it, everyone stood like in the fitting room, and you have those, you know, the 3 mirrors that are hinged, and you can kind of, you know, make them so that you can see yourself in the mirror, and you see yourself like curving off into infinity. But the propagation delay there is like the speed of light, right? So it's completely not observable. Also, I think about, how many times can I say propagation delay? But I think about that concept, you know, with electronics, and it's a lot harder to understand. But then when you show it here, you immediately get it, and it feels very approachable.
And although I love this video, this is absolutely calling out for someone who has a few projectors on hand to actually do it upright and project them against a wall big enough so that people can walk into the display, interact with it, make their own fractals by like dancing around in it. Oh, I have this in my head as like the coolest interactive museum exhibit I've ever seen.
I predict Fractal Elliot will make an appearance before the end of this summer.
I've got 2.
You can definitely find a friend to loan
in my
one.
closet. Yeah. I can find another one.
I do not have a Nintendo Switch, Elliot, but I really want one.
Yeah, we've got one.
Actually, you do have one?
My wife has one, officially.
Have you been afflicted by the drift of the Joy-Cons?
No, I don't know why, but not at all.
Huh. Well, you're lucky, because it seems to be a big problem, or maybe that's just, you know, confirmation bias. There are a ton of people out there who report that the analog thumbsticks on their Nintendo Switch Joy-Cons, which is the name for the controllers for them, if you just leave them sit there, they're supposed to return to the center of the joystick. but it'll slowly drift on screen as if you're, pushing to one side just ever so slightly. It feels like it's been years that people have been complaining about this, but VK's channel has a video that claims to be able to fix this. For me, I'd like to just see the teardown of those joysticks, the switches themselves. They're pretty simple in the mechanism. It's basically like a trim pot where you have like a carbon pad on the printed circuit board, and then you have a metal sweeper that moves across it as you move the joystick, and then the variation in voltage can be easily measured. And the theory has been that there's a problem with the contacts, so you're like getting dust or dirt in the contacts. But what VK actually finds here is that if you press on the face and the back of the Joy-Con, the problem will go away. And his theory is that the bottom of the thumbstick switch, not the Nintendo Switch, but the bottom of the module itself, which is like a metal housing that kind of grips the other parts of this joystick switch, is getting bent just a little bit, and it's adding a little bit of extra space between the sweeper and the carbon. And then perhaps, it's a multitude of problems. Combine that with dirty contacts, and you end up with a bigger problem. And the fix here is you put a piece of like construction paper underneath it, and that tolerance, it just like holds it there.
Yeah, I'm looking at the cutaway diagram here, and you could totally imagine that it's surface mount soldered on kind of the peripheries of it. And so if you press down repeatedly in the center, and it's got a finite thickness of solder holding it up around the edges, that's of course going to make it dome in the more you press on it. And that would explain why the shim works really well too.
Yeah, I think that there are several different like makes of them if you're tearing these things down. So you would think that they've been iterating on a little bit, but think about the abuse that game controllers take. I mean, it's just shocking how like I've had I've had the PlayStation 1, 2, 3, and 4 now, and like all those controllers have been fantastic workhorses to the point where I've even like taken them apart to clean them and put them back together, and they still worked wonderfully for years. Even I think the wireless ones, the batteries have never been a problem. It's some of the best engineering must be going into these game controllers. It's sad that that this seems to be one of the few persistent problems. Although I think people have complained about analog sticks from Nintendo gaming consoles for a while. I remember the N64 seems to have problems with legacy systems and the analog joystick on those.
It's funny you mention that, because I took apart some of our Wii remotes a couple weeks ago because some of the buttons stopped working, and I thought, I'll just pull them open and clean the contacts. Had to order a special like tri-wing screwdriver to get in there, but $4 and wait for eBay fixes that. Open them up, and the switches in there are just so beautifully designed. They have those little rubber caps over the little carbon pill part, but then they have seals on them that go up and over a plastic molding. And so if you spill water into this thing, it's not going to get into the contacts. I have no idea how ours got dirty, messed up. I mean, they're 10 years old or whatever. Maybe that's it. Anyway, cleaned them up, marveled at the engineering, screwed the whole thing back together, and we're playing again.
Oh, that's great. Yeah, I have 3 Wii remotes, and one of them we're not using because it will just randomly shut off in the middle of your bowling.
Oh, that's not good.
And you do not like that to happen. So I figured that was probably a power supply issue, like something's happening and it's resetting the chip. But haven't opened it up yet. Maybe I'll be brave like you.
I'll mail you my tri-wing screwdriver. My last hack this week isn't really a hack. It's Tales from the Global Chip Shortage Smoothie Board Edition. Chris Cecil, leader of the Smoothie Board project, wrote up a blog post about the troubles he had sourcing a particular microcontroller. This was the LPC 4330. So the story with the Smoothie Board is that Chris Cecil had just got them sent out to the contract manufacturer. They'd looked it over, they'd okayed it, and then they wrote him back saying, we don't have any more of these LPC 4330 microcontrollers anymore. They got sold out from under us.
Oh, rough.
And so what are you going to do? And the answer is panic a little bit. They came back to him a day later saying, oh, wait, we can get them for you at 5 times the original cost, which put Chris to thinking. And this is an interesting thing that can happen to you when you run into adversity like this. At first he was like, oh man, do I just suck it up and buy the expensive microcontrollers? And then he's like, I never really liked those anyway. This may be a chance to buy something new and do a little respin of the board and, fix up some of the things that were wrong with it. And so he took that opportunity. And I love that, the kind of, external forces kicking you in the head and then just standing back up and saying, wait, I can make it better anyway. And so he swapped out to the STM32H series H745, which ironically is now completely out of stock at DigiKey and Mauser.
Right.
I actually checked right before the show. They might have bought up the last 100 of them that were out in the wild. Who knows? Anyway, the good news is that it just took a tremendous firmware rewriting and porting, which Clement and some others helped him with. So a new and improved smoothie board is out. They've got the chips that they need, and it's all going to come out in the end. But it just goes to show that even once you've agreed to, an assembly contract with a manufacturer, they might have trouble sourcing what you need. And this could come out to bite you.
Yeah, certainly. So this smoothie board is really popular for CNC controllers, especially 3D printers. And one of the things is that since it's open source hardware and it's been funded through crowdfunding, there are updates on like how this has been going. And so in the comments of this article, Arthur Wolf popped in and said that he's nearly done writing an update to the Kickstarter about this. And so it'll be interesting to hear some more details on it. But what a good example of the practice of firmware writers of keeping the hardware specific parts like in a different set of files, so that if you need to move something somewhere, the pain is hopefully centralized to a place that you can find and not like sprinkled throughout, thousands of lines of code. This next one is an optical hack, and I've never yet had to make a mirror, but if I did have to make a mirror, I would be completely lost were it not for the type of help that we're getting on projects like this one from Volzo. Volzo is looking at what it takes to make custom optics, and we're not just talking about a flat plane of a mirror, but we're talking about mirrors that are bent, mirrors that are domed, mirrors that are in a different kind of shape. And I encourage you to go and look at the article that Tom wrote on this one for the image at the top, because it's just so cool to see the parts that go into this. You're going to see a miniature vacuum forming table. So it's just like a piece of hardboard about the size of a slice of bread that has a bunch of holes in it. It has a 3D printed shape in the middle of it. And then under this, there's like what I assume is a 3D printed funnel shaped base that can be plugged into your shop vac. And then there's a frame that has the reflective material on it and a heat gun. And so you use the heat gun to get that reflective material to be to the point where it's kind of melty. And then you turn on your shop vac and you bring this down onto the vacuum table and it sucks it into place. I think there's so many different parts of this. One of the really hard ones, though, is figuring out what the heck is that reflective material. And that's how the video starts off. And so we get a look at things like what happens if you try it with acrylic. And there are some shots where you're reflecting things, you're like reflecting a test pattern off of these optics. And then I think he does a negative shot, or is it infrared or something like that? You get this alternate shot and you can immediately see like striations from trying to do it with acrylic, because acrylics isn't very flat and it's got some texture to it. And anything you're doing optically is going to amplify that problem. And so it ends up coming down to using a reflective material that is polystyrene. And you can get it in different thicknesses. And Volzo has all kinds of advice on where to go with those thicknesses.
That's really cool. And you can get all sorts of bizarro custom effects out of this because, you can make conical mirrors that take something projected up at it and project it out, 360 degrees around you. There's all sorts of crazy, interesting ideas that combined with, the ability to make arbitrary images with computers and then spread them out through a projector, you could do some really cool effects. How does he do the modeling to figure out the shapes that these things need to be in?
Yeah, so that's a really cool part as well. And so it's actually done with Blender and the ray tracing ability of Blender. So you can kind of make your shape, and then he shows you can set up the ray tracing either with a light source in Blender, which is Blender is an open source 3D modeling program that's often used for making animations. But we've seen it used for a bunch of other things. It's a pretty full-featured tool that a lot of people complain about the user interface. But I mean, come on, who doesn't complain about user interfaces?
You complain about the user interface of a rocket ship too. It's complicated, yo.
Yeah,
it has to be complicated.
Sorry. I mean, I'll admit, I've tried to use Blender. I've actually made photorealistic models in Blender, and it's intense and hard. But I mean, it was like a one-off project. What do you expect? You got to kind of get in bed with these things to really understand them. One of the cool parts is that Volzo started with models in Fusion 360 that were the device that the mirror needed to interact with. And those were exported as STL files and then imported into Blender. And then the design in Blender was put on top of those and then tested with the ray tracing and then exported for 3D printing and then put through this vacuum forming process. It's something that, the majority of people listening or looking at it are never going to do, but everyone's going to respect the length that it took to get this far. If this sounds familiar to you, it's because we just talked about using ray tracing for optics a few weeks ago on that CNC scroll saw blade tracking hack. I'll put that into the show notes as well, but you'll want to check out both of those if you haven't seen that one already.
My first quick hack this week is extracting the Wi-Fi firmware and putting back a keylogger. This is a marvelous demonstration of why I want to learn 8051 programming. 8051 enthusiast has pulled apart his Wi-Fi modem from his laptop and discovered that inside is an 8051 chip, among other things. Let's see, he's able to dump both the Wi-Fi and the Bluetooth software, and because he knows 8051 assembly, is able to install a keylogger in it just for fun, put it back in the computer, and everything runs. 8051s are everywhere, but of course they're archaic, but them being archaic means they're in all sorts of devices, so maybe it's worth learning, give you a lot of power. Next up, ManaWorm, the internet on a Casio calculator. This is fantastic. ManaWorm wrote himself a TCP/IP stack for the Casio FX 9860/9750 series calculators. A lot of these old calculators have enough brains in them that they're worth doing this sort of trick. He's also written an IRC client, a terminal, and as a final last flourish, a web server running on a calculator. And last up, MIDI Mouse makes marvelous music. KZRA took an old PS2 mouse and plugged it into an Arduino and then plugged this into a computer. The Arduino sends MIDI messages, and when he goes in the X direction, it changes the pitch. The Y direction changes the velocity and the volume. And then the buttons do funny effects, a vibrato and a glissando and stuff like that. It just looks like a really fun alternative way to play music, and it's easy enough to make. You should probably do it if you got a PS2 mouse lying around.
First up on my list, an OLED photo frame powered by the AT-Teeny 85. This whole thing is about the size of a stick of gum. It has a coin cell battery for power, and it has one of those little OLEDs that's about the size of your two thumbnails put next to each other. And it's an interesting programming challenge for you to take on if you're interested in embedded systems, because you can figure out, how do I get an image to show well on this small screen? How do I store those images onto this chip that has limited memory? And now that I've stored those images and don't have room for libraries, how do I directly drive the SSD 1306? None of these things are hard, but you put them together and it's a nice little weekend programming challenge. Next up, Ball Balancing Wheel puts a spin on inverted pendulums. I am a sucker for these PID loop demonstrators that balance something. I talked a little bit about building the test rig to do one with a ping pong ball a few weeks ago. That was just kind of like a flat thing that pivots in the center and the ball rolls from one side to the other. This one changes that up. You still have a ball, But instead of a flat surface for the ball to roll left or right on, the surface is a larger wheel. And so you're balancing the ball on top of the wheel. I also thought it was interesting because we were just talking about these FOC motor controllers last week, and here's a good example of one being used. And finally, faulty electrolytic caps don't always look bad. So oftentimes when you have older electronics and they stop working, your geek friend will tell you, oh, it's probably bad capacitors, you should replace those. And I've always kind of thought that you could figure out which ones were bad because the vent on the top of them would be domed up where they've kind of gone bad, but that turns out not to be the case. And Zach Kemble kind of walks us through how to test these capacitors, and don't give up hope if they're not domed. It might still be just an easy capacitor swap to resurrect your old equipment. It's time for our can't miss articles of the week. This is awesome long form content written by excellent Hackaday writers, and I think we've chosen 2 Tom Nardi articles this week.
It's Space Week on Hackaday. My pick this week is a look back on a decade of Kerbal Space Program. And this is the video game that launched 1,000 careers or 1,000 hacks or I don't know what. Is it a video game? It is a simulator. Anyway, Kerbal is 10 years old now. And in celebration of that anniversary, the last official update has been released for the game. The makers of Kerbal are looking forward to next year putting out Kerbal Space Program 2. It's going to be multiplayer and big and fancy and complicated and who knows what. But the charm of Kerbal itself is that it was both a game and a simulator. And so it would draw you in as a game, but it had enough physics and kind of orbital mechanics to make it interesting and to make it so you could learn something at the same time. It was easy to make mods for. I think the most amazing thing is that both NASA and the European Space Agency kind of realized that people were playing this and the physics was real enough that they would contribute to the project too, because it's helping get people interested in and trained for space stuff. I think we also saw a ton of people like making their own custom cabinets for it. There's a lovely photo gallery in this article of like some of the really amazing looking controllers that people made for their own Kerbal stuff. I don't know. I just think it's really cool that a game has such good physics, but then also such good visualizations that it caught on with a lot of people, but then like serious space scientists would use it to demonstrate docking maneuvers. And when the people at NASA are wasting their time playing the same video game that you are, it just kind of feels good, right?
Yeah, did you get into serious space research because you played Kerbal, or did you get into Kerbal because you were really into space research?
Exactly.
I think the cool part of this story is that this company was not about making games, and this was one of the employees' side projects. And I think they recognized they had lightning in a bottle and put resources behind it, and it took off like crazy. The problem, Elliot, is you can't get the same result if you set out to do it. Like, it's one of those things where the planets just aligned onto something. You ended up getting a really addictive game that happened to be really educational on things that are generally difficult to learn. And, very few people would be studying them. And I think that's amazing. And if you're running a game company, please, please, please find out how to do this with the next big thing.
I think that's true. And if you go through the comments, you will see the argument about whether it's a simulator or a video game and, kind of what the difference between those would be anyway, right? And I do think that's a great object lesson. You're not going to have a runaway hit if you just make a really awesome simulator. You have to also somehow make it fun. And whatever it is that Kerbal did, they definitely hit it out of the park.
All right, the last can't miss article of the week is also a Tom Nardi article entitled "This Group of Women Tried to Break into Astronaut Program in 1960s. One Just Made It." And it goes into a really awesome backstory that I'd never heard before that starts back in the 60s. But the jumping off point was from Monday morning when we had a launch of Blue Origin. Their rocket took up someone named Mary Wallace Funk, also known as Wally Funk. She had gone through training, privately funded training in the 1960s in a bid to try to break into the astronaut program, which at the time was all men. Ended up not being successful, but had realized that her lifelong dream of going into space. I think that's really awesome. I know that, in general, most of the media was focused on Jeff Bezos going up. And I think on the one hand, like, this story was probably a way of giving some cover to the tone deafness of billionaires going into space, but it is worth your time to go in and dig into this one. This group of women is often known as the Mercury 13. In talking with Tom about the story, that's kind of a misnomer because they were never officially associated with any of the NASA programs. The problem that they were faced with is that the benchmarks that you had to achieve to get into the astronaut program basically eliminated any women from being eligible. Some of the requirements are reasonable, like having a degree in STEM and having experience as a pilot of jet aircraft. In both of those cases, women did qualify. So during the Second World War, women were flying jet aircraft that were coming off of the production lines and had experience with that. They were called the Women Air Force Service Pilots. But there was a requirement added by Eisenhower that you had to have active duty military in your background. And so even though they were flying these planes, they were not considered active duty military, and it eliminated them from this. So how do you get around the problem of not being able to get into the astronaut program? Well, one of the ways that they could go at it is it was easy to say, well, there are no women that are qualified to be astronauts. And so they attacked that first, and they set out to go through the same qualifications, like I said before, privately funded, in order to break down that argument. I was talking with Tom on it. It sounds like there was only one person, Jerry Cobb, who made it through all of the qualifications, because when Jerry went out and recruited 19 other women to join this program, by the time they started going through the different levels, NASA had then, prohibited them from going through the final certifications because NASA controlled the equipment that they would be training on.
I mean, it kind of does strike you as a little bit unfair, and the active military service component a little bit arbitrary. I totally understand the, having them trained in orbital mechanics and having higher science degrees to support this, because this was back in the day when the computer's going to fail and you are going to have to figure out how to get yourself back down. And so that, of course, made a ton of sense back then. I just think it's interesting to contrast this with Valentina Tereshkova, the seagull, who actually ended up being the first woman in space. She was a Russian cosmonaut, and she was an avid skydiver. And they took her because of that. That was like, her qualifications to get her into the training program there.
Well, I was surprised to find out that we didn't have a woman astronaut make it to space until 1983 when Sally Ride did. And so
isn't it crazy?
It is crazy. I mean, we're talking about, 20 years since this group of women tried to get into the program for it to actually happen. And, I will say that from what I've learned about the space shuttle program, NASA did make a big effort to diversify the astronauts that were going up. As far as the skydiving goes, I mean, that makes total sense to me. That's a great qualification. One of the things that was kind of put forward is that it should be people who had been test pilots. And I think that was relaxed a little bit later. But, when you're strapping someone to experimental rockets and sending them into the vacuum of space where, maybe only a handful of other people have gone, that is scary. Like, you need people who are going to operate and thrive under life-threatening conditions. That makes some sense, but that's also why the qualification programs had things like they would do sensory deprivation tanks, they would do G-force testing, they would do all kinds of this testing. So I think it's interesting that, Jerry Cobb made it through, and for me, it's a great look back at a portion of the space race that I hadn't learned about before, and it just makes me feel really good to see Wally Funk make it finally. That's all the time we have for this episode of the Hackaday podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you see something cool, please tell us about it. tips@hackaday.com. And until next time,
Keep on hacking.
oh, I just ignored you.
Good man.
I would like to... No, I can't. Shoot. Hello? Hello, I don't hear anything. Are you still there?
You don't hear me? Hello?
I've lost you.
I'm still here.
Elliot, can you hear me?
Hey, yup.
Maybe your computer died.
Me, ma, mama, moo.